Okay, ladies and gentlemen, welcome back to the review for Pre-Calculus Marking Period 2 Progress Check. This will be the last one dealing with the last word problem with the Ferris wheel and other things like that, the sinusoidal problems. So it says the Ferris wheel has a radius of 26 feet. It takes 8 seconds to go from the bottom of the Ferris wheel to the very top of the wheel. So that's actually really important. And it says your maximum height off the ground is 60 feet. So right here, from right there, is going to be 60 feet. And then you are the last person to board the ride. Now, there's going to be some assumptions that the last person on is going to be at the lowest specific point. So it says sketch the graph height and feet in seconds. So seconds is going to go here. Feet is going to go here. Now, something to keep in mind that the radius of the actual Ferris wheel, so from here to here, is going to be 26. So the lowest point is going to be another 26 from there. So both of those together would give you 52. And so that means that this distance from here to here is going to be 8 feet. So that's actually also going to be really important. So 60 from the top, 8 from the bottom, and just double checking, that should add up to be 52. And then since you're the lowest person to get on, so that would be at 8. And then some time will pass and then you'll end up getting to the highest point in a sinusoidal curve. Now they also say that it takes 8 seconds to go from the bottom of the ride to the top. So that would be 8 seconds. And then to get back down, it will take 16 seconds. So let's write down all the values that we know. So the maximum, 60. Minimum, 8. Period. So how long does it take to go from the bottom to the bottom? And that would be 16. And then the amplitude, which is my A value, is going to be max minus the min divided by 2. So A is going to be equal to 60 minus 8 divided by 2. So it's going to be 52 divided by 2, so that's going to be 26. My B value is going to be 2 pi over the period. So it's going to be 2 pi over 16, so that's going to be just pi over 8. My C value is, in a sense, the phase shift. So if I'm using cosine and using that point as my starting point, I'm no distance away from the y-axis. So C is going to be equal to 0. And D is going to be the midline plus the A value. So the mid is 8 plus 26. And so that ends up giving us 34. So my sinusoidal equation is going to be y equals, I'm going to do this in terms of cosine since that does the lowest point or the highest point. So I'm going to write down the amplitude. So it's going to be 26 cosine of pi over 8, x minus technically 0, and then plus the d value, which is 34. But something to also keep in mind is since I'm starting on that low point, if I'm dealing with cosine being at its low point, I need to actually make this negative because cosine, when it's negative, starts at its low point. And that is going to be my equation. If you did want to change this so that it was positive, it would be y equals 26 cosine of x, pi over 8, x minus 8 plus 34. So what that will do is that will make that top point my phase shift of where I moved it over. Excuse me. Oh man, having a coughing fit. Ugh. So I could either have one of the two equations. All right, number 16. So this is the one value that you're going to have to use your calculator to be able to figure this out. But on the progress check, you are actually not allowed to use the calculator. So I can show you how to set this up, but for the most part, you don't need to worry too much details about this. The important thing is to remember what does dt stand for and what is, well, there's excuse me. For the most part, just being able to determine what the variables stand for. So this is, in a sense, the depth, and this is specifically the time. You can take a look at the answers and figure out what the values are from there. I'm actually not going to go over this one. Um, just make sure that you have this idea that you are able to use it. Like if you were using your calculator, you could figure out the values based around that specific equation. But I'm actually going to kind of skip that. Okay, number 17. It says a power plant generates electricity over the 24-hour period. And so it looks specifically like this. So a couple things to notice. So it does a 24-hour period. It goes from the high point to the high point. So max is 90. Min looks like that's going to be a 10. My period, 24. And then I should be able to kind of set up my whole value. So A is equal to max minus the min divided by 2. So that's going to give me 90 minus 10 divided by 2. So that's going to give me 40. My B value is going to be 2 pi over the period. So it's going to be 2 pi over 24, which is also pi over 12. Now my C value, it looks like that it's right on the y-axis. So I don't need to worry about a different C value. So I'm going to say C is going to be equal to 0, specifically if I'm working with cosine as my high point or my low point. And then my D value is going to be the minimum plus the A value. So the minimum here is 10 plus 40, so it's going to give me 50. By the way, just to double check, does that look like the middle between, in a sense, the high point right here to there, and there to there? Does that look like that's going to be the amplitude? So 40 here and 40 here. Looks like it to me. So y equals the A value, which is going to be 40 cosine of pi over 12, x minus 0, yet again because there's no phase shift, and then plus 50. And the reason why this is not negative here and positive is because we start at this location right here, which if it starts at a high point, it is going to be the positive value. Okay, and that should finish up this review. I'm sorry about this last one I ended up having a little bit of a coughing fit and turned off my mic and other things like that. So if there's some weird pauses in there, that's the reason why. All right, thanks for watching. Hopefully that this was helpful. I am available for help today or in the comments below. But yeah, good luck on your progress check, and thanks for watching.